Hello, everyone. I welcome one and all in today's session of workshop on research methodology and data analysis using SPSS software. Um, Today, resource person is Mr. Assaye Belay, and he will talk about all t-tests, one-way ANOVA and two-way ANOVA in SPSS. It's my pleasure to introduce Mr. Assaye Belay to all of you. Mr. Assaye Belay completed his BSc degree in statistics from Volga University in 2010. He had been assigned as assistant instructor 1 and 2 by Ministry of Higher Education in Mizan Tepe University, Ethiopia. After 2 years of service of teaching, he joined Zima University to study MSc in biostatistics and graduated in 2015. He has more than 8 years of experience of teaching statistics course under Department of Statistics, College of Natural and Computation Science. He is now research coordinator of Mizan Tepe University, Tepe campus. He has got his research papers published in many international journals and has more than 17 citations. He also wrote book on probability and statistics for engineer. He is actively engaged in community service and he gave training on research methodology and statistics to academicians and research scholars at Mizan Tepe University. Besides his office duties, he is actively engaged in research, teaching, and community service. I welcome you, sir, and I express my gratitude for accepting the invitation and being part of the workshop. Over to you. May I request Mr. Assaye to kindly start his presentation? And I'm very much sure that it will be very beneficial for all the participants, and it will definitely add to our knowledge. Over to you, sir.
Okay. First, I'm going to forward my gratitude for the organizers. Just the organizers, committee, and Mizan Tepe University staffs, and the Mickey Math Thinking Foundation for the organizations. Just I am happy to be a part of these issues to present the PowerPoint that going to present the all tests, all t-tests, and one-way ANOVA and two-way ANOVA. Before we are going to discuss the all t-tests, we are going to say something about what statistics mean. Actually, much more definitions has given from the previous speakers, but now for the summary, just we summarize in the diagram ways. Just we can classify statistics just as inferential statistics and descriptive statistics. Why we classified here, I'm going to see all tests. So before we are going to all t-tests, we have to say something about t-test and hypothesis testing and estimation. Just all jointly, hypothesis testing and estimation are jointly described, generalizing from sample to population, performing estimation, hypothesis testing, determine the relationship among variables, and making predictions. This is all about hypothesis testing, and estimates are jointly describe what inferential statistics mean. Here, in statistics or in research, we have to set to hypothesis testing. What hypothesis testing is stated about. Just we say something about the statistical hypothesis. Just before make a proposal, before make a questionnaire, we have to set our hypothesis. Why? Because we have an input to predict the outcomes based on the hypothesis testing. Just we can have null hypothesis denoted by H naught, and we have alternative hypothesis if it is true, if null hypothesis are rejected. In reality, while testing any population parameters and estimations, two types of errors has been occurred. Here, the status of this session that we set hypothesis testing is H naught alternative hypothesis. For instance, actual situation or realities can be formulated while testing any population parameter and estimations, and what decision were expected to did. For instance, if the hypothesis is correct and if we accept it is a correct decision. If the hypothesis or the actual or the situation or the reality is incorrect, then if we accept that is type 2 error we did. If the actual, okay, okay, then what is p-values? What null hypothesis and p-values? What p-values can we did? What we consider? What type of error can we are going to make? What type of errors can be committed while testing the population parameters? Just having said that, we say something about estimation and hypothesis testing for population means. One sample test, independent sample test, paired sample t-test, analysis of variance. One sample test, as the name indicates, when we do any experiment and a measurement, that measurements can be done from one population group. Why we use one sample test? If we use independent sample test, the two samples comes from two independent populations. The assumption is as it is as well. And third, paired test. If the paired test can be used, if the population is dependent and the outcome is measured before and after experiment. Okay, the analysis of variance actually, the comparison of what means, comparison of means or comparison of more than two means. Actually, one is the extension of what, two is the extension of one sample test. Paired test and independent sample test is, I think, to contract each other. Why? Because independent sample can be obtained from different population groups, but paired test is measured from the same group before and after event. Analysis of variance, just we can measure compare the population means more than two and so on. What is the nature of one sample test? What is the nature? One sample test is determined whether the sample comes from a population with specific means. Here, the null hypothesis, if it is visible actually, nu which is equal to what? Hypothesized mean. Why? Because the null hypothesis always assumes no differences, no difference whatever. And the alternative hypothesis, just we always assume the differences, Just our decision is based upon the types of hypotheses that can be made here. Whenever an experiment is done, we can have an hypothesis testing, either null hypothesis or alternative hypothesis. Actually, the data for all is continuous and comes from normal probability distributions. This is the assumption. All classical statistics, classical statistics, of course. For instance, the shelf life of carbonated beverage interest, 10 bottles are randomly selected and tested, and this amount of observation can be taken and measured in days. Then set appropriate hypothesis testing for investigating the claim about the population mean is 132. This 132 is the hypothesized mean. How can we enter the data? Just we can go to the one sample test. Okay. The null hypothesis 132, and the alternative hypothesis is different from 132. To test whether it is true, just we can have this amount of data that can be observed by researchers. Here, hypothesized mean that can be tested whether the null hypothesis 132 and the alternative hypothesis 132. Just here is Spss output actually. The p-value is 0.875 means it is p-value is less than 0.05. So we can test this using Spss. Here is the burning time that can be observed. Actually, it is numeric or burning times. No, it is a scale measurement that we can judge it. Here is the one sample test can be done from the example given before. So this data maybe judges whether H note is rejected or accepted. Just we can have the Spss menu, then we are going to go in the mean function here, it is one sample test. One sample test. Here we can enter it. The testing value is 132. The tested value is 132. Then we can judge or we can consider alpha values, which is 95 or 5% level of significance can be considered. Actually, we can judge or we can use either 99% or 95%, but computer by itself or by default 95% can be used. So we can judge it. Here, okay. Here is the T calculated. Actually, we can compute either using manual, but the software can generate certain outputs. The degree of freedom, which is 10, 10 minus 1 is 9, and the significance or p-value is 0.875, it is two-sided t-test. If it is 1, you can divide it by 2, but our hypothesis is two-sided side tests. Here is the mean differences. Here is also the confidence interval we have. The confidence interval and hypothesis testing, just we can use interchangeably, right? So we can go to two sample tests. Two sample tests. Two independent sample tests. As I have said before, the sample is taken from two independent populations. Two independent populations. This is the assumption. The sample is measured from different groups or populations that are independent. So the same is true for one sample test, just we can set out the hypothesis testing for two independent sample tests. One, or null hypothesis always assume equal, means what? The mean from the sample that comes from one population is, which is equal to the mean for come from the second populations. This is always true under null hypothesis. But if it is not true, the alternative hypothesis can be accepted. The mean for H1, new 1 is different from new 2. So we have to have an evidence or in statistics in a data to judge whether it is true or false. This is the reality of what? Hypothesis testing that can be done in any experiment. For instance, here the following are the burning times in minutes or chemical flares of two different formulations. And two, for the design engineers are interested to emboss designs, which is formulation 1 and formulation 2. Therefore, our hypothesis can be judged either the mean for the population that comes from formulation 1, which is equal to the mean for population 2 for formulation 1. This is an experiment setting which can be done by researcher. So is that the mean for formulation 1 always equal to the mean for formulation 2? If it is rejected, just we can accept the second one. Actually, in statistics, in Spss, how can we enter the data? Means what? Here, formulation 1, formulation 2. The number indicates what? The time. Just we can code for formulation 1 and formulation 2 by using codes. In statistics or in Spss, somebody wrongly entered the data. So how can we enter the data means what? Just it is a burning time, it is continuous actually. And 0 for formulation 1, 1 for formulation 2, and the number is considered for burning times as a continuous. Therefore, we can set as NSPSS, then we can go to the data we have. We have two sample tests. Here is, okay, sorry. Here is the burning time. Just we can enter the data as it is, but how can we code the types of formulation? 0 for formulation 1, 1 for formulation 2, Therefore, we can enter the data as it is. Burning time, you can write just it is a burning time. We can write burning time as the statement. It is not clear. You can write whatever you want. Whatever it is, BT means burning time of chemical flares. Here is formulation, either coded from 0 or for formulation 1, 1 for formulation 2. Then it is no matter how to analyze two independent sample tests. Just we can go to analyze mean independent sample tests. Here is the burning time is a continuous and can be entered as tested values. Since it is continuous. Here is the formulation or types of formulation as a group variable. Just we have already coded like 0 and 1. Here is formulation. So we can define what a value is assigned. 0 for formulation 1, 1 for formulation 2. Then we can go to the an option. It is 95. By default in statistics, 95 confidence interval is considered. 95% confidence is by default. If an experiment data which can be done in health, it is 99%. Here, 5% error is tolerated. 5% error is tolerated means 95% confidence we have to judge the data. Here we can have an output. As we said, the population that comes from two independent populations, then we have to compare the mean by assuming equal variances, equal population variance. Here, F test, maybe it is not a part of this, but to test the mean differences, we have to check about the F test, whether the ratio of 2 and 2 variants are equal. Here, equal variance is assumed because the p-value 0.825 means it is not significant. Means what? The variance for population 1, which is equal to what? The variance for population 2. It is equal variance is assumed. Therefore, we can judge it. The degree of freedom is 18 and the p-value is 0.01. And the mean difference here, the standard error here, the confidence interval is minus 18.398 and minus 2.804, which means p-value is less than 0.05. So the null hypothesis rejected that we have already stated before. Here the mean for burning time for formulation 1 different from the mean for burning time for formulation 2. Just we can see the PowerPoint or the output is that already here is p-values 0.01 means less than 0.5. The null hypothesis is rejected at 5 level of significance. Why? Because 95% confidence is we already set it, so that the mean is different from two formulations. So we can compare the mean from two independent sample tests. The other one is paired test. When we do an experiment, maybe the sample is taken from the same individuals or the same groups. For instance, the heart rate can be measured before exercise and after exercise. So the same event, I mean, the outcome is measured before event and after event. Therefore, we can set the hypothesis always. An experiment sets as the event before the mean before the event, which is equal to what? The mean before the event, after the event. But this may not be true. So we can set new one different from new two means what? The event before some treatment or some other chemical maybe, or any experimental units. So the event may be different from the event after the treatment is given. Maybe it depends upon the experiment they are going to formulate. For instance, the dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by certain mineral. 6 subjects were pre-tested and took a mineral supplement for a week period. And the cholesterol level measured in milliliters. So we can check that the cholesterol level can be reduced before and after the mineral is given. Here, this sample is measured before the event, or this number can be measured before the experiment is done, or before the mineral is given. Here is the second row, or the number for the second row can be measured after the mineral is given. So the hypothesis can be formulated as the mean, what is the difference between before and after is that the cholesterol level is reduced before and after the mineral is given. That is the hypothesis stated. So we can set as the hypothesis testing. So it is straightforward for entering the data in Spss. It is directly to enter the data. So the mean for cholesterol level before diet, which is equal to the mean for cholesterol after diet, it is the null hypothesis, actual realities. But the alternative hypothesis, the mean cholesterol level before diet is different from the mean cholesterol level at diet. So we can test it. So the p-value is still large, which is 0.169 greater than 0.5. The null hypothesis is not rejected at 5 level of significance. Thus, there is no significant difference in the cholesterol level between before and after diet supplemented by dietary certain minerals. So we can go to the data actually. Okay. Here is the data. We can enter the data before. Again, we can enter the data after. It is all are numeric. So we can write the distribution of the data, and it is measurement scale is ratio. So we can the data, we can have the data before and after. Therefore, we can go to the mean, and here the test. So we can enter the data cholesterol before, and we can enter the data for the next variable cholesterol after. And the same is true for the previous one. We can have 95%, which means 5% error is tolerated, or alpha is 0.05. Therefore, we can run it. Therefore, cholesterol level before diet minus cholesterol level after diet. It is a positive values or standard deviation here. All summary of statistics can be obtained here. So still the p-value is 0.169, which is large. Therefore, we can judge nothing is, the food is nothing that reduce the cholesterol level, which means the cholesterol level before and after the diet is similar, no effect as well. Here is, it is the hypothesis testing we have. Okay, here is the p-value is 0.169 greater than 0.5, then the null hypothesis not rejected at 5 level of significance. Thus, there is no significant difference in cholesterol level between before and after diet supplemented by experiment, minerals. Actually, the experiment is based upon our event. Maybe the experiment is differ for different fields. Okay. The other one is one-way ANOVA. As we said before, the target for all are comparing means. The one-way ANOVA compare the mean of two or more groups based on independent sample or factor for any experiments. Here, whatever an experiment is done, we can compare the mean for independent events, independent variables. We can compare. If it is one population group, we can use one sample test. If two groups, we can use two independent sample tests. If it is more than three, we can use one-way analysis of variance. Why we use one-way analysis of variance? Just we can consider one factor having their labels. One factor may have two labels, may have three labels, may have four labels, may have 8 and 6, whatever, have their own labels. So we can set an hypothesis testing for one-way ANOVA. New one, which is equal to new two, which is equal to new k, means what? The measurement can be done from one group is, which is equal to the mean for group 2, which is equal to new k. It is depends upon the number of parameters that can be compared. The alternative hypothesis, at least one mean is differ from other group means. Therefore, this hypothesis testing can be actually formulated before an experiment is done. an experiment is done. But one-way ANOVA can tell you which group are significantly different from one another. For instance, here, manufacturers of television sets interested in the effect of conductivity of 4 different types of coating for color picture tubes. The following conductivity data are obtained. Here is the coating type that the designer can be formulated. Coating type 1, coating type 2, coating type 3, coating type 4. If you have another coating type, you can add. So this conductivity measured in number. So this an observation can be obtained from coating type 1. This is the number of the conductivity measurement can be obtained from coating type 2. Here is conductivity can be obtained from coating type 3 and so on. So we can formulate the null hypothesis just that we have said before. The mean for all are equal. The mean for all are equal. It is the same is true for 2 independent and 1 sample test. Here, at least one mean differ from others. Here is the data formulator just we can design. Here is the first 0 is coded for coating type 1. 1 is coded for type 2. 2 is coded from type 3. Okay, it is typing error for 1, 2, 3, 4. You can understand by saying 1, 2, 3, 4. It is typing error. Just we can correct it. Quoting type 1, quoting type 2, quoting type 3, and 4. So we can go to the data. How can we analyze one way of analysis of variance? Here is the continuous variable conductivity, or can be written here. And the second column writes the code that we can be assigned for types of coating. So we can have coating type 1, type 2, type 3. And the second is 3, 4, it is true. So we can enter the data about here. Therefore, we can go to analyze one-way ANOVA. Here is conductivity is a dependent variable, and coating typing is a factor. Here is the contrast is no need of here. It's an option. It's a discrete statistics. We can add. So we can write here. Here is coating type 1 is the discrete statistics already summarized here. Number is 4. The number is 4 for each. This is 16. And the mean is given, standard deviation, standard error, confidence, upper and minimum. All discrete statistics can be obtained here. Here is the one way of ANOVA, which is between groups or some square treatment. Within groups, sometimes called error. The same analysis can be made here. We can use general linear model, then univariate. Conductivity is the dependent variable and coating type is a factor. Then we can have select the model is full factorials. So we can write here. Also, we can feed the model. The corrected model here. The intercept is given here. The coating type is here. 3 minus 1 means, or 4 minus 1 is 3, the error term is given and the total is the correct, so we can fit the ANOVA model from here. So we can see, we can interpret as it is. Since the p-value is 0.00 less than or equal to 0.05, the null hypothesis is rejected at 5 level of significance. Then we can conclude that at least one mean is differ from the mean. However, it does not tell us which mean is differ from others. Why? Because the mean is different, but which one is differ from others? No magnitude can be stated using this. So we can use another technique, which is multiple comparisons. We can compare is that significant difference between coding type 1 and 2 and 3 and 4. Coding type 2 we can compare with coding type 1, 2, 1, 3, 4, and so on. So we can have pair comparisons. How many groups? Which has 4, or combination 2 is 12. Why we have 12 pairs are given here? 1, 2, 3, 4, 5, 6, and so on. So for instance, coding type 1 is different from a significant difference between coding type 1 and coding type 3, since p-value is less than 0.05. The same is true for coding type 4 and 1. Again, we can compare 2 with others. And again, we can compare with 3 to others. And again, we can compare 4 with others. So we can judge the mean or the significance difference within the group. Okay. So here from the multiple comparison, coding type 1 and coding type 2 and 1 and 2 and 3 are a significant difference. So we can interpret for each if it is significant. The last is two-way analysis of variance. Just one way of ANOVA can be used for only one factor having a label. But two-way ANOVA can be used two factors having their labels, even if one continuous outcome can be used for one-way ANOVA and two-way ANOVA. Why one-way ANOVA? Just only one factor can be used. Why we use two-way ANOVA? Two factors having their labels can be used. Maybe the data is nominal, maybe ordinal. If it is covariate, we can use another technique, which is ANCOVA. So we can test for the significance, which is interaction effect, and mean effects. Two-way ANOVA can be also employ independent variables. If it interval and ratio, we can scale as covariates. So we can use ANCOVA, or we can use simply multiple linear regressions. Here is a very interesting example to illustrate two-way ANOVA. Actually, the example may be focusing on for either economics or engineers and whatever. Just we can take as an example and you are expected to change to your experiment. For instance, the researcher wished to see whether the types of gasoline how the types of automobile have an effect for gasoline consumption. How many factors we have? Two types of factor we have. Types of gasoline and types of automobile. For the contribution, for either significant contribution for gasoline consumption. For instance, the one may use gasoline or regular and high octane, and types of automobile, they may use two-wheel or four-wheel drive, so will be used in each group. There will be 2 automobiles in for each, for a total of 8 automobiles can be used. Why it is two-way ANOVA? The question is why it is two-way ANOVA? Why? Because 2 factors can be considered here. One, types of automobile. Types of automobile having 2 labels. For instance, the one who study about the gasoline consumption only using types of gasoline, just the one can use one-way ANOVA. Again, the one may be independently study about the gasoline consumption using what? By studying the types of automobile or using one-way ANOVA. But for interactively, we can use two-way ANOVA to study the interact effect for gasoline consumption. Okay. Here is, for instance, an experimenter. For instance, the experimenter can outline the data. For instance, the types of automobile that can be set as two-wheel drive and four-wheel drive. Again, types of gasoline can be outlined as regular and high octane. So we can observe the data. 26.7 can be used either regular and two-wheel drive. The same is true for 25.2 for two-wheel and regular. The same is true for regular and four-wheel. The data is labeled as here. High octane for two-wheel, it is 32.3. High octane for two-wheel, 32.8. High octane for four-wheel, 26.1. High octane for four-wheel, 24.2. So how can we enter the data into Spss? The question is here. Actually, we can enter the data into Spss, then we can export for another software. Therefore, how can we enter the data? The question is how can we enter the data? A very difficult for entering the data for two-way the experiment data is what? Maybe the one entering the data directly, but you may get wrong information and wrong conclusions. So we can go to two-way ANOVA. Here, to avoid the confusion, I have set the data for label for different. For instance, the first one types of gasoline 1, 1, 2, 2, 1, 1, 2, 2. But what labels can we have a sign. Here is regular, regular, high octane, regular, regular, high octane. So the same is true for the second row. The data is labeled here. So we can apply the same procedure for a species mean for general linear model for univariate. The gasoline consumption is actually before analyzing, we can say something about here. Gasoline consumption is a number, it is continuous, and types of gasoline is coded, just I have already coded it, one for regular, two for high octane. And again, types of automobile, I have coded for 3 and 4 to make avoiding a confusion. So we can analyze the data for mean, then univariate gasoline consumption. So here, a dependent variable or the gasoline consumption depends upon the type of factor we have. So we can enter and we can enter. So we can a full factorials, okay? So we can write, we can run it. Therefore, the types of gasoline is 0.095, it is not significant. Types of automobile 0.27, 0.027, it is significant. And their interaction effect is 0.001 means significant. So how can you interpret it? If there is an interaction effect, no need of interpreting the main effect. If the interaction effect is not significant, we can interpret the main effect. Therefore, here is actually 0, 1 high octane. Actually, we can code it as. Then we can do the same analysis for their interaction effect. We can analyze for the general linear model, and we can plot it, whether there is interaction effect. Then we can enter in the horizontal, we can enter for the separate lines. Then we can add the plot. Then okay. Okay, this is the model. The one can make a model or ANOVA model, just the intercept here, H naught, I mean beta naught. Here is gasoline beta 1, and types of automobile is beta 2, and types of automobile and gasoline is beta 1 times beta 2, the interaction effect. So this is the error term. So we can feed an ANOVA model. Here is the interaction effect we have. Okay. So again, we can run it. We can run the add plots already. here is the plot. Here is the plot. This plot indicates that there is an interaction effect for types of gasoline and automobile interact effects for gasoline consumptions. Therefore, no need of interpreting separately. So, okay. If the interaction is significant, then interpret along with mean and plot. If there is no significance, main effect becomes relevant. So if there is interaction effect, so we cannot interpret independently. So thank you very much. I hope we will more discuss from your questions that you are going to raise for the presentations. So if you have questions regarding today's presentations, one-way ANOVA, two-way ANOVA, and so on, welcome.
Thank you, sir. I request the
Okay.
participants to come forward with a question, if any.
Okay.
There are a few questions in the chat box from
Okay.
Saintu. The question is why that the numerator 132 is claimed even. It is not in the set of observation.
Okay. Okay, second question.
Second question is how the SPSS tool is applicable for engineering researches. Would you mind to justify this clearing by using some examples?
Okay.
Should I tell the next one?
Okay.
The next question is from that 4T test analysis, which one is recommended or best compared to the other methods?
Again. Sorry. Would you repeat again?
From the 4T test analysis, which one is
Okay.
recommended or best compared to the other methods?
Okay.
And the one more question from Hamad Not. I hope I'm pronouncing it correct. That
Okay. Okay.
let me see which is the question.
Okay. Action.
The question is, I have confusion with difference between t-test and chi-square. He has got confusion with difference between t-test and chi-square. And Mr. Daniel, I don't know, show multiple, he wants to us to you to show multiple comparison to select which one is different using the software. So these are the questions from the participants. And one more question has come up. How do we test for homoscedasticity and heteroscedasticity using SPS? And one more question is, sir, can be done cause effect analysis with the help of t-test? So these are the questions from the participants. Would you like to address?
Okay. Would you repeat the last questions?
How do we test? I'm sorry. The last question is, can we do cause effect analysis with the help of t-test?
Okay.
So these are the questions from the participants.
Okay. I'm going to react as much as I understood was a question raised, and I expect more discussion were expected from us. 132 is not a part of the data. I think the question is here. 132 is not a part of the data. Okay. So actually 132 is the hypothesized mean or the realities that can be formulated under the null hypothesis. Actually, the null hypothesis, it is assumed to be true until it declared false. For instance, shall I show the PowerPoint? I think it is better to show. Okay. Okay. All right. Here is. I think the question is 132 is the population means, which is not a part of here. But here is 132 is the idea that can be formulated by some researchers said before is 132. But we can't believe. As a researcher, we need to have a data to judge whether it is true or false. Why we said H naught is 132 and our research hypothesis is the new is different from 132. Why we need the data to say whether this 132 is ideally true, the shelf life of carbonated beverage interest is 130. So based on the data we have, we can reject it is not true. But for the analysis, of course, here is the hypothesis. We don't believe that. H naught is 132, already stated. The researcher, maybe the realities that can be stated before can tell us, simply believe the mean for the shelf life of carbonated beverage is 132. So we cannot believe that. We can take a data. So 10 data are selected to judge whether it is 132 or not. So based on the data, actually from this analysis, the p-value is 0.875. What is the null hypothesis is not rejected, so we can accept. So the mean is already the same. So it is not a part of the data, but somebody are stated the hypothesis, but a researcher, we can take the data to judge with it, which is equal to 132 and not. That is why.
Thank you, sir.
Okay, actually more discussion is needed about the null and alternative hypothesis. The second question is, Spss for engineering. Actually, Spss is the software that can be manipulated the data. So the design is expected from us. For instance, the chemistry engineers, for instance, here, for instance, the burning time here, it is unapplicable even if the example is focusing for one specializations. But here, the expected designers are designed the formulations, right? Here is an example for design engineers, maybe chemist engineers, or whatever engineers are expected to formulate an experiment, whether to use one-way analysis of variance and two-way analysis of variance. Spss is simply the software that can be generated and outcomes. So much more effect is needed from the design engineers. So Spss actually is a tool, a software can be generated, can be analyze the data. Even the data is exported from Spss to either SAS or R and whatever. Therefore, Spss is simply a software that can be used to get an output from the design of an experiment. That is. So don't confuse about the Spss. Even don't believe that for Spss for social science. Now, Spss is statistical product solutions. It is very important. Okay. Among four tests, which one is best for other methods? Actually, the test depends upon the population that the population mean that can be compared. If it is the sample is measured from one population, we can use one sample test. We can use only one mean, a single mean. We can test that a single mean that can be computed from the same population, while with one sample. Their function is different. Again, two independent sample tests actually, it is depends upon the experiment we did. Only two populations are taken, only two samples taken from different populations, we can use two independent samples. So how can we compare one sample test, two sample tests, and so on? It depends upon the experiment we did. One population is measured, one group, and one sample is measured from another group, then compare whether the mean that comes from one population is different from one sample from another population. So two independent samples can be used for two population groups. Again, paired, actually the paired test is similar to independent sample test, but can be measured for the same individuals. The same. For instance, if the one can measure the heart rate for an individual for different times before exercise and after exercise, so we can measure the data before and after experiments, whether the heartbeat is decreasing before experiment, before exercise, and after exercise. Therefore, paired test is very applicable for dependent event. Again, one-way ANOVA, of course, it is similar to two-way ANOVA. It is extension of two independent sample tests. It is extension of two independent sample tests. We can compare more than two means. It depends upon the parameters that we are going to compare. So one-way ANOVA, only one factor, but having K labels. One factor with K labels. So one is the extension of the another, but we can't compare one is another. It is not a method to compare like a model. So it is a tool that we are going to apply whether the experiment did a single population to independent population, even a population having more than categories, of course, one sample. So to ANOVA, actually, I mentioned that the two interaction effects can be considered for. So which one is best is depends upon the experiment that we are going to formulate. The designer having their experiment, and the medical biotechnology have their own experiment. The chemists have their own experiment. Even the social science has their own experiment. So we need to use appropriate tests from the experiment. Okay. The third, so it depends upon the experiment we did. And fourth question is t-test and chi-square test. It is extremely different. T-test is simply used to compare the mean for the population. And the samples comes from normal distributions. Actually, the distribution is not shown here, but It is similar to normal distribution, but can be applied if the sample size is small and the variability is unknown. The population variance is unknown. It is symmetric. T-test is symmetric distribution. It is negative to the left and right to the positive to the right, but it is symmetric each others. Therefore, t-test can be used for comparing means and the data in normalized distributions. Chi-square test is simply to use to compare or test the variance, or right skewed. Actually, the one we can use or see the graph of chi-square test is 0 up to right skewed. It is not symmetric, or used to compare the variances. But t-test is used to compare the mean. So it is extremely different. Again, chi-square test is used for associations or either homogeneity or association, whatever it is depends upon. Multiple comparison actually is a good question. Tiki test. I've used tiki test here. Here, the comparison just we can analyze. So one sample test here. One sample test. Here, post hoc comparison. Post hoc comparison, if you click post hoc comparisons, you can use either least significance differences, either use Born-Feron, either use the, but now the sample size is actually equal or balanced. Randomized design, we can use Tiki test. So I have used Tiki test to show here. Okay. Have you seen it? Have you seen? The one who raised the question, have you seen how to use? The output is post hoc test using Tiki test. Even you can use least significance tests. So I have used Tiki honest significance difference tests. Many options can be obtained from the menu, but you can use inappropriate ways. So most of the time, if it is randomized design, we can use t-test or individual t-test. Okay. Actually, homoscedasticity test means homogeneity of variance means we can use either the normality assumption or normal test or histograms. We can use homogeneity tests here. Actually here it is an homogeneity subset here, of course, here. Here homogeneous subset tests can be used, the homogeneity of the variances. The variance is the same for all. Actually, the assumption for the continuous t-test, either two independent sample test, the data is continuous and assumed to be random, normal distribution having a constant variance. It is an assumption of what the continuous response variables. Okay, the last question, case effect actually it is a medical word, but may I misinterpret here? But only we need to test a factor. And we need to see on track the factor which affects the outcomes, but it is a medical outcome, cause and effect. The cause is a factor, and effect is an outcome. Of course, the one may interpret, the health may interpret as cause and effect, but most of the time we have used as a factor and effect that an outcomes. And more have any question? Okay, welcome. And more discussion will be expected if you have any question again.
If there is any question, you are most welcome to ask. Thank you so much,
Okay.
sir. I guess you have addressed all the questions and answered all the questions patiently. Thank you so much for your time. It was indeed a very well presented and very well organized presentation, very well organized lecture. And I'm sure that
PDF
all of
kasalagu
the
de latin lach.
participants, do you want to ask something? Is there anyone asking something? Okay, I guess someone has unmuted his mic, but really it was, I am sure that it proved to be very informative and very knowledgeable session for all the participants. Thank you so much, sir, for your time. And I would like to thank participants also for asking questions and commenting that they are all very impressed by your presentation and all are commenting well. Thank you, everyone. Thank you, everyone, for joining. And I request participants to kindly fill feedback forms as soon as possible. And the link for the same is there in the chat box. Thank you, everyone, for joining. We'll resume tomorrow. Thank you so much.
Thanks.
I beg your pardon, participants. I would request Dr. Meher Chand to kindly present certificate to the guest resource person of the day. Dr. Meher Chand, kindly present the certificate to the resource person of the day. Thank you, sir.
Yes. Okay. Okay. Thank you.
Thank you, sir. Thank you, everyone.
Okay.